Use the limit definition of a derivative to find f prime of a, where f of x equals 3x divided by 5x minus 1. This is one of those problems that can freak people out if they don't like a lot of algebra. So my advice is to just go very slow through the problem, check your work. If you make a mistake, it's okay. As long as you write everything neatly, you should be able to figure out where the mistake was. Okay, let's try and do it. Take a deep breath. Here we go. So this asks us to use the limit definition of a derivative, and there's two ways that you typically see this. One way, which I'll do first, is the limit as x approaches a of f of x minus f of a divided by x minus a. So let's actually calculate this. So I have the limit as x approaches a of f of x. Okay, that's 3x over 5x minus 1 minus f of a. That's 3a over 5a minus 1 all over x minus a. And now you can see where the algebra is going to come into it. We're going to have to deal with this crazy fraction that we have here. So first thing that you can do is create a common denominator on the top. So 5x minus 1 and 5a minus 1, well, there's nothing in common really there, so our common denominator is just going to be 5x minus 1 times 5a minus 1. So for the top here, the first one, we're going to have a 5x minus 1 and a 5a minus 1. And if I put a 5a minus 1 on the denominator of this fraction, I'm going to have to put it in the numerator also. So I have a 5a minus 1 up here. Same thing for this one. It's also going to be 5x minus 1, 5a minus 1, and I'm going to have to put a 5x minus 1 up here. And this is all over x minus a. Okay, let's move over here. So now I have the limit, and this is the limit as x approaches a of. So now I can combine this into one fraction on the top. So that's going to be 5x minus 1 times 5a minus 1 for my denominator there. And I'm going to have 3x times 5a minus 1. So let's write all this out. 3x times 5a minus 1 minus 3a times 5x minus 1. And that's all over x minus a. All right. So not too bad so far. It's kind of messy, but you'll see it simplifies a lot at the end. So now I have the limit as x approaches a of. And at this point, I'm dividing the whole thing by x minus a, but dividing by x minus a is the same thing as multiplying by 1 over x minus a. Remember, dividing is the same thing as multiplying by the reciprocal. So if I want to, I could move that x minus a down here and just have one fraction. So let's do that. So I have x minus a, and then I'm going to have 5x minus 1 and 5a minus 1. And then on the top, let's multiply this out. So I have 3x times 5a, that's going to be 15xa. And then I'm going to have a minus 3x. Then I have a 3a times a 5x with a minus sign here, so it's going to be minus 15xa. And then minus 3a minus 1, that's going to be plus 3a. And look, 15xa minus 15xa, gone. So I'm left with the limit as x approaches a of, and I could, if I want to, multiply all this out in the denominator, but I'm going to say when you're doing these types of problems, avoid multiplying stuff out until you really have to, like especially complicated things like this, because sometimes things cancel and you're better off not multiplying stuff out. So I'm going to leave it as x minus a times 5x minus 1 times 5a minus 1. And in the numerator now I have negative 3x plus 3a. Well, I can pull out a negative 3, and then you'll see a nice cancellation will happen. So if I write this top as negative 3 times, and then it's going to be x minus a. Negative 3 times x, that's my negative 3x. Negative 3 times negative a, that's my positive 3a. And then in the bottom I have still x minus a, 5x minus 1, 5a minus 1. And now you can see why I didn't multiply that out, because look, x minus a, those are gone. So I have the limit as x approaches a of 5x minus 1 times 5a minus 1 in the denominator, and then in the numerator I just have negative 3. Now I can actually do the limit. If I were to plug an a in here, I would get 5a minus 1 times 5a minus 1. That's just 5a minus 1 squared. So my final answer is 5a minus 1 squared. In the bottom, I have a 3 on top. It's negative, so it's negative 3 divided by 5a minus 1 squared. Okay, so that might seem like a lot of work, and it kind of is. It's a lot of algebra. But like I said, as long as you go through it slowly and really check all your work, you should be fine. Now, I said there's a second definition that you sometimes see for the limit definition of a derivative. Let's take a look at that. Okay, so the second definition looks like this. We have the limit as h approaches 0 of f of a plus h minus f of a all over h. So let's plug in. We have the limit as h approaches 0 of f of a plus h. That means everywhere you see an x, you replace it with a plus h. So I'm going to have in the bottom here 5 times a plus h minus 1, and then on the top a 3 times a plus h minus, and now I have f of a, so everywhere you see an x, replace it with an a. Looks like that. And on the bottom I have h. Okay, so again, I'm going to have that same thing where I need a common denominator on top. And again, not too much in common here, so unfortunately I'm just going to have to make it this big complicated denominator. Let's do this down here, just make sure I have enough room. So I have the limit as h approaches 0 of. So first I'm going to have 5a plus h minus 1 times 5a minus 1. And I'm going to have 3a plus h, and I multiply the bottom by 5a minus 1. That means I'm going to have to multiply the top by 5a minus 1. Okay, and then here I'm going to have the same denominator, 5 times a plus h minus 1 times 5a minus 1, and on top I multiplied everything by 5 times a plus h minus 1, so I'm going to have to do the same on the top. I have a 3a times 5 times a plus h minus 1, and all of this is divided by h. Yuck. It looks kind of messy, but again, it's going to simplify. It's not going to be this bad. So I have the limit as h approaches 0 of, and I have this h on the bottom. This is going to combine into one fraction on top, and remember, dividing by h is the same thing as multiplying by 1 over h. So I'm just going to stick the h in the bottom here, and it's going to be h times, and then this is going to be my common denominator. In fact, I'll multiply this out. So I have parentheses in parentheses here. I'm going to have 5a plus 5h minus 1 times 5a minus 1. And on the top, I'm going to have this whole thing minus this whole thing. So it's going to be 3 times a plus h times 5a minus 1 minus 3a times, and I'll multiply it out, 5a plus 5h minus 1. Okay, do not multiply the denominator out yet. Like I said, oftentimes you see things cancel, so rather than waste your time multiplying it out, let's hold off on that. In fact, this pesky h right here is the thing we would like to go away, because if we could cancel that h out, then we'd be okay to do the limit. We wouldn't be getting a 0 in the denominator anymore. And as you'll see, that's exactly what's going to happen. So I'm going to have the limit as h approaches 0 of. So the top part, I'm going to have 3 times, let's multiply this out, a times 5a, that's 5a squared. And we'll do the outer term, a times negative 1, that's minus a. And the inner term, h times 5a, that's going to be plus 5ah. And the last term, h times negative 1, that's negative h. And then multiply this out. That's going to be 3a and 5a with a minus sign. That's going to be negative 15a squared. Then I have negative 3a plus 5h. That's going to be negative 15ah. And negative 3a, negative 1, that's going to be positive 3a. And then my denominator stays the same. Not going to multiply it out. H times 5a plus 5h minus 1 times 5a minus 1. And now I can distribute this 3 on top, so I'm still going to have the limit as h approaches 0, and it's going to be 15a squared. And it's going to be negative 3a plus 15ah minus 3h minus 15a squared minus 15ah plus 3a. And then the bottom is going to stay the same. That's going to be h times 5a plus 5h minus 1 times 5a minus 1. All right, we're almost done. I see some cancellations here. 15a squared minus 15a squared minus 3a plus 3a plus 15ah minus 15ah. So what's left over? I'm going to have the limit as h approaches 0 of. On the top, I just have negative 3h. That's nice. And on the bottom, I have the same thing that I had, and you can see now that that h, that pesky h that we had in the bottom is going to cancel, which is exactly what we wanted to happen. So this h and this h, gone. And so we have the limit as h approaches 0 of, on the bottom, I just have 5a plus 5h minus 1 times 5a minus 1. And on the top, I just have negative 3. And now I'm ready to take the limit. If I let h go to 0, this term disappears, and I just get 5a minus 1 times 5a minus 1, and I have a negative 3 on top. So it's going to be negative 5a minus 1 squared down here. I'm going to have a 3 on top. And so I get negative 3 divided by 5a minus 1 squared. And that's the same thing that we had before.